Welcome to Edipin channel. Before we continue, be sure to hit that subscribe button as well as that notification bell so that you do not miss any content from Edipin channel. So in this lesson, basically what we're going to do is that we're going to learn about momentum. So in everything that you learn or any topic that you learn, you need to start with the definition of that particular thing that you want to learn or study. So in this case, we are going to learn about momentum. So momentum is basically a product of the mass of an object as well as its velocity. So a product is the answer that you get when you multiply two things, so as to be clear. So why exactly is momentum a vector quantity and not a scalar quantity? It is a vector quantity because if you take a mass is a scalar quantity. So if you multiply a scalar by a vector, the product that you get actually takes the direction of the vector that is in the problem that you are given. So we know that velocity is actually a vector quantity. Why? Because a vector has both magnitude plus direction. So that is why we say that a momentum is a vector quantity. It actually takes the velocity's direction, and so it will be having both magnitude as well as direction. So momentum is a physical quantity that is related to forces, and it's a property that applies to a moving object, and in fact it's an object in motion. So anything with a mass that moves, it actually has a momentum. So if something has a mass and it's moving, then it has momentum. So there are a few things that you should know about momentum. So momentum is indicated by a letter P with an arrow on top of that P to show that it's a vector quantity. So it has both magnitude as well as direction. And the mass of an object is actually indicated by the letter M, and the velocity, if you remember well from your previous grades, it's actually indicated by a letter V with an arrow on top to indicate that it's a vector quantity. So the formula for your momentum, it's actually P, which is equals to mv. As I've said, that momentum is actually a product of the mass of an object as well as the velocity at which this object moves with. So the additional information that you need to remember when it comes to momentum, so we have the first point, which says that momentum is directly proportional to both the mass as well as its velocity. So if you have a car which is moving at a velocity of 2 meters per second and its mass is actually equals to 20 kilograms, the momentum of this car is going to be equals to 20 multiplied by 2, which is equals to 40 kilograms meters per second. And then if you increase the velocity of this car to maybe 3 meters per second, let's say here it's 3, you can see that you are actually going to have momentum which is equals to 60 kilograms meters per second. And also, if for example you leave your velocity as it was, and basically what you do is you increase your mass, and your mass you make it 30. So 30 multiplied by 2 is going to be 60. So our momentum has actually increased, so it's going to be 60 kilograms meters per second. So as you can see, the momentum has actually increased. While we had a mass of 20 kilograms multiplied by 2, we actually had momentum of 40 kilograms meters per second. But immediately when we increase the size of velocity as well as the magnitude of the mass, the momentum keeps increasing. That's why we say that momentum is actually directly proportional to both the mass as well as the velocity of an object. And then we come to the second point. So the second point is that the mass is directly proportional to the momentum and it's inversely proportional to the velocity of an object. For example, if we make the mass the subject of the formula, we are going to have, let's start from the original formula. We have momentum, which is equals to mass multiplied by velocity. So if we make mass the subject of the formula, we're going to have m, which indicates mass, which will be equal to momentum all over the velocity. So if you increase the momentum, the mass is also going to increase. But that's why we are saying that the mass is actually directly proportional to the momentum. But if we increase the velocity, as you can see that the velocity, it's the denominator of this expression, you're actually going to see a decrease in the mass. But if you decrease the velocity, you will see an increase in what? An increase in mass as well. And then we continue. So the vector nature of momentum. So a car that is traveling at about 60 kilometers per hour, it will have a smaller momentum than that one which is actually traveling at 120 kilometers per hour. For example, let's make things simple and say that we have a car with a mass of 20 kilograms and it's traveling at velocity of let's say 2 meters per second. And then we have another car that actually has the same mass of 20 kilograms, but then it's traveling at the velocity of 3 meters per second. Let's say this one is car A and this one is car B. So for car A, its momentum is actually gonna be equals to 20 multiplied by 2, which is equals to 40 kilograms meters per second. That's for car A. And then if you go to car B, its momentum is gonna be equals to 20 multiplied by 3, which is equals to 60 kilograms meters per second. So from this example, you can see that if you have two cars with actually the same mass but different velocities, they will actually have different momentums. So the one with a much higher velocity will have a magnitude of momentum that is much higher than that one with a velocity that is smaller. And then the other point that you need to know is that different objects can also have the same momentum. For example, a car as well as a motorcycle. So, for example, let's say that a car actually has a mass of 5 kilograms and a velocity of 2 meters per second. 2 meters per second. And also we come to a motorcycle which has a mass of, let's say, 2 kilograms and it's traveling at a velocity of 5 meters per second. So for both this objects, when they travel, they're actually going to have the same momentum, So let's check it. For example, so this is our motorcycle. It has a mass that is 2 kilograms, which is less than that of a truck. So this one is gonna be our car, not a truck, by the way. So in this example, the momentum of a car is actually going to be equals to 5 multiplied by 2, which is equals to 10 kilograms meters per second. And if you come to the motorcycle, which has a much lesser mass, we're going to have a momentum which is equals to 2 multiplied by 5, which is equals to 10 kilograms meters per second. So as you can see, objects with the same with the different masses can actually have the same momentum, and objects with different velocities as well can also have the same momentum. It just depends on the velocity that the car is traveling with. You can have the same momentum, no matter how small it is, it can have the same momentum as a bigger car that actually is traveling at a lesser velocity. Right, now that you have actually learned about momentum and how to calculate it, as well as its important characteristics and properties that you need to know about momentum, now we have to actually apply what we have learned. So we have the first problem. So in this type of problems, it is necessary for you to actually write what you are given in the problem along the way while you are writing the whole statement that you are given. So for example, a soccer ball of mass 420 grams, you write what you are given. We are given the mass. So the mass is 420 grams. Is kicked at 20 meters per second towards the goal post. So we are given also the velocity, which is equals to 20 meters per second. And then we have to remember our formula. So our formula is actually P, which is equals to mv, momentum, which is equals to mass multiplied by the velocity. So we need to check our mass. The unit in which our mass is actually in grams, but because when we momentum is actually its SI unit, it's actually kilograms meters per second. We actually have to convert this 420 into kilograms. So to convert that into kilograms, you just have to divide it by 1,000 and you will get 420 divided by 1,000. You will get 0.42 kilograms. So we come to our momentum. So momentum in this case is going to be equals to the mass, which is equals to 0.42 multiplied by our velocity, which is 20 meters per second. Or you may not write them yet, the SI unit as yet. So you have 0.42 multiplied by 20 meters per second. So our momentum is actually equals to 8.4 kilograms meters per second. And then we come to problem 2. So with problem 2, a cricket ball is actually bowled at 40 meters per second at a batsman. So we actually have our mass. Which is equals to 160 grams. And we also have our velocity, which is equals to 40 meters per second. So in this case also we can see that our mass is actually in grams, not in kilograms, so we need to convert it by dividing it by 1,000. So 160 divided by 1,000 is actually 0.16 kilograms. So the formula for momentum, it's P, which is equals to mv, So our mass is equals to 0.16 multiplied by 40, which is our velocity, and then 0.16 multiplied by 40 is actually equals to 6.4 kilograms meters per second. So basically, what you need to do in order to always get your momentum calculations correct is to always make sure that your mass is actually in kilograms and your velocity it's in meters per second, or your speed is in meters per second.